In this video, I want to have a look at graphs involving transformations of our inverse trig functions. So before we look at transforming them, we have to remember what they actually are and how we restrict the domain. So we've got our cos inverse, sine inverse, and tan inverse graphs drawn here, and the domains that we've restricted them to. All right, so let's have a look at some examples of transformations. Our first example asks us to sketch y plus pi on 2 equals cos inverse of x plus 1. So because it's cos inverse, what we're starting with is this graph here, and then we have to look at how that's transformed. So this plus pi on 2 here, because it's y plus pi on 2, that means that our whole graph is going to shift down pi on 2 units. This plus 1 in here with the x, that means that our x values, so our whole graph, is going to shift left 1 unit. Well, left needs a t in there as well. So the whole graph, this whole graph is going to shift down pi on 2 and left 1. So that means if we look at the down first, instead of going between pi and 0, instead we're going to go between pi on 2 down to minus pi on 2. It also means if we're shifting it left 1 unit, instead of it having a domain of minus 1 to 1, we're instead going to be going from 2 to 0. Now that point 1 is still important because instead of now crossing the, having an intercept here, that's going to move down pi on 2 and across 1. So our graph is actually going to cut through the axis here. So we're also going to have our graph starting here at 2 pi on 2. It's going to curve down through that 1 and then back down here. So the whole graph has remained the same shape, it's just been shifted. So we're also asked to state the new domain and range. So our domain now, instead of being between minus 1 and 1, is now between, those should be negatives there. It's now between negative 2 and 0. And our range, instead of being between 0 and pi, our range is now between minus pi on 2 and pi on 2. Our second example asks us to sketch y equals tan inverse of minus x plus pi on 2. The first thing I'm actually going to do here is rearrange this a little bit. So we're going to have y minus pi on 2 is equal to tan inverse of minus x. All right, so we can have a look at two things there. This minus pi on 2, that's going to shift our whole graph up pi on 2 units. And this minus x here, that's going to flip our entire graph across the y-axis. So this graph here is our starting point. So if we were to flip that, we know that our graph is going to start higher up on the left and then curve down towards the right. So we're flipping that over. But we also need to shift it up pi on 2 units. That means that instead of having asymptotes at minus pi on 2 and pi on 2, they're instead going to be at 0 and pi. So the first thing I'm going to do is draw in that asymptote, and that is at pi. And we know there's another one along here at 0 as well. We also know that our y-intercept, instead of being at 0, has moved up to pi on 2 now. Okay, so like we said as well, it's shifted direction, so it's starting up here, and we're going to curve down this direction instead. All right, so we're also asked to state the domain and range of this new function. The domain is still going to be all real x, or you can say it's between negative infinity and infinity. And the range has been moved up, so our range is now between 0 and pi. So that's having a look at transformations of our inverse trig graphs.